Here we have a SAT math question. Okay, let's go with the information. In Miss Lee's class, the number of boys is more than twice the number of girls. There are at least 7 girls and there are no more than 15 boys. How many students are in the class? Okay, so let me assume B as the number of boys in the class. Let me write over here. And also let G be number of girls in the class. Let me write it. Okay, the number of students is given by T equals, that is total number of students in the class equals to number of boys B, positive number of girls G. Okay, we have to find the value of B and G. There is a number of boys and number of girls, and we have to add them to get the number of students in the class. So for that, we have to use the information we have over here. Okay, the first information says the number of boys is more than twice the number of girls. So that is B, that means the number of boys is more than twice the number of girls, and also there are at least 7 girls. That is, the number of girls has to be equal to 7 or greater than 7 according to this information. That is, G has to be greater than or equal to 7. And there is another information, that is there are no more than 15 boys. So the number of boys B can be equal to 15 or it has to be less than 15. So these are all the information we have in the question. We know that B is greater than 2G. So here G is multiplied by 2. Since G is multiplied by 2 over here, so in this inequality also we can multiply both sides by 2, so that we will be getting 2G on the left side. Okay, when I multiply both sides of this inequality by 2, I am getting 2G greater than or equal to 14. Okay, here we have 2G, here we have 2G. So we can combine these two inequalities. When I combine these two inequalities, I am getting B greater than 2G greater than or equal to 14. Okay, here B is greater than 2G and 2G is greater than or equal to 14. Then this B must be greater than 14. So B is greater than 14. Already we have an inequality with B, that is B is less than or equal to 15. Okay, now we can combine these two inequalities. So that is 14 less than B less than or equal to 15. I just combine this one and this one. So when I do so, I'm getting I'm getting a compound inequality, 14 less than B less than or equal to 15. Then what value that B can take? And we have to remember one important thing: both B and G must be integers, because B and G represent number of boys and number of girls respectively. So they cannot be decimal. So B has to be an integer. So we have to find the value of B so that it has to be greater than 14 and it has to be less than or equal to 15. There is only one integer which satisfies this compound inequality, that is 15. So therefore B equals to 15. Okay, now I got the value of B, that is 15. Okay, now let's find the value of G using this inequality. In this inequality we can plug in that B equals to 15, then we get 15 greater than 2G. Okay, to solve for G, let's divide both sides by 2. So when I do so, I'm getting 7.5 on the left side, and the right side this 2 will cancel. I'm getting G. Okay, so here otherwise what we can do is we can write this inequality as G less than 7.5. Okay, already we have an inequality with G, that is G is greater than or equal to 7. Here we have G is less than 7.5. We can combine these two inequalities. When I do so, I'm getting 7 less than or equal to G less than 7.5. Okay, already we know that G has to be an integer because it represents the number of girls. So G has to be less than 7.5. At the same time, it can be equal to 7 or greater than 7. So the only integer value which satisfies this compound inequality is G equals to 7. Okay, already I got the value of B, that is 15, and now I got the value of G, that is 7. That is number of boys in the class is 15, number of girls in the class is 7. So to get the total number of students, we have to add them. That is 15 positive 7, so which is equal to 22. So the number of students in the class is 22. We find 22 in option D. The correct answer choice for this question is option D.